Hi, in this video we are going to see about a Python IEEE project which is entitled as Sleep Disorder Prediction Using Machine Learning, which is an enhancement of IEEE base paper title Applying Machine Learning Algorithms for Classification of Sleep Disorders, which is an IEEE 2024 journal paper. Before seeing the execution of the project, let me brief about this project. So we all know that sleep is very important for the human being. In case if you're not having a good sleep, so we'll be having both mental and physical disorders. So nowadays, due to the change in lifestyle, many people are affected by this sleep disorder. So identifying a scientific approach for this sleep disorder will be helpful to the patients. So in this base paper, so author have been introducing the machine learning algorithm for the classification of the sleep disorder. So in the base paper, so the authors have used various algorithms like K, nearest neighbors, support vector machine, decision tree, random forest, and artificial neural network (ANN) deep learning algorithms. And the results, he has finalized that the ANN achieved the highest classification accuracy of 92.92%. Kindly note that we are not going to use the same as mentioned in the base paper. So now let us see about our proposed system model. So in our proposed system, we are going to use two different machine learning model. The first one is gradient boosting classifier and second one is quadratic discriminant analysis. Now coming to the accuracy that we have achieved. So here you can see the training accuracy of the first model, that is gradient boosting classifier model. The training accuracy is 96% and the test accuracy score is 95%. And coming to the second model, quadratic discriminant analysis, we have achieved training accuracy of 92% and test accuracy of 92%. So compared to the existing system, we are introducing two different models and we have improved the accuracy when compared to the existing system based paper model. And in our proposed system, we are going to add this and also make some analysis of the data set. Let us see about the details. So coming to the abstract document, so here you can see our proposed title and here the IEEE base paper title and the IEEE base paper abstract. So coming to our proposed abstract, so the sleep disorder prediction using machine learning is developed using Python. The front end part contains HTML, CSS, JavaScript and utilizing the Flask framework. And as mentioned, we'll be using two different models, gradient boosting classifier and quadratic discriminant analysis. And coming to the data set part, so here you can see we are using the sleep health and lifestyle data set. So the sleep health and lifestyle data set contains 15,000 data set records with 13 features. So now let me show you the data set and then come back to the abstract part again. So here you can see the data set that we are going to use to train our model. So just scroll down, you can see that it contains 15,000 data set records. So the features like person ID, gender, age, occupation, sleep duration, quality of sleep, physical activity level, stress level, BMI category, blood pressure, heart rate, daily steps, sleep disorder class, label. So these are the features that is available. So this is the person ID they have taken to identify the person, and gender male or female, and age category, occupation like doctor, teacher, software engineer, lawyer. So they have categorized those details from the data set. And sleep duration, they have taken how many hours they are sleep, so 6.65, 6 hours, 7 hours, 8 hours, like that. And quality of sleep, so they have categorizing the quality of sleep from 1 to 10, like that. So that is being given in the data set. And physical activity, this is the minutes, 15 minutes they have used physical activities for the whole day, 30 minutes they have used, like that. It is the minutes. And coming to the stress level, they are categorizing the test level 1 to 10. And BMI category, so based on the weight, normal weight or overweight or abnormal weight, so those would be BMI categories. And blood pressure level according to the BP level, and heart rate level, and daily steps, how many steps they have worked a day. So those details have been given here. And coming to the class sleep disorder. So this is the data set that we are going to train up the system. And coming back to the abstract part, so here you can see about the accuracy that we have achieved and all the details have been summarized here. Coming to the existing system, so we are taking the base paper as the existing system, so they have used artificial neural network, so those details have been mentioned in the existing system in detail. And disadvantages of the existing system, so here we are listed the disadvantages of the existing system. And coming to the proposed system, as mentioned, so we are going to use the gradient boosting classifier and quadratic discriminant analysis model in this. So with the dataset record and the sleep, health and lifestyle dataset details and the model details, everything is being summarized here in the proposed system. And coming to the advantages of proposed system, so we have listed about the advantages of the proposed system. Now let us see about the system architecture. So in the system architecture, we'll be giving the sleep, health and lifestyle dataset as input, and pre-processing and feature selection is made, and the two models, that is gradient boosting classifier, quadratic discriminant analysis, is used for training. And finally it is classified as three classes, that is healthy, insomnia or sleep apnea. So in our project we'll be having three classes. So healthy means there is no any sleep disorder available. Second class is insomnia. So insomnia is a type where the patient will be having a problem of falling in asleep. So they'll be having problem in having the starting of the sleeping part. And third one is sleep apnea. So sleep apnea is like a problem like when the patient sleeps, they'll be having some pauses in their breath, so that the entire sleep will be collapsed and they cannot sleep again. So due to this breathing during the sleep. So this is a type of sleep disorder. So our project will be having these three classes: healthy, insomnia, sleep apnea. And finally we'll be having the performance analysis parameters and the graphs for the project. And coming to the system requirements, these are the hardware requirements and software requirements. So this can be executed in Windows 10 or 11. Python coding language that we have used is 3.12.0. Web framework is Flask. Frontend part contain HTML, CSS and JavaScript. So this is the reference of the IEEE base paper that we have taken. So now let us see the execution of the project. So before execution, make sure that you have fulfilled the requirement that is mentioned in the requirements file with the exact version of the Python and the libraries installed in your system. So now let me go to the source code. Inside that we have this classification of sleep disorders folder. Inside that we have the app.py. So here let me type cmd in the address bar. So the command prompt window open with the exact location of it. Now type python app.py and click enter and kindly wait for a few seconds. Now you can see this URL. Just copy this URL, go to any of your browser. I'm going to Chrome and paste it and click enter. So now you can see the home screen or welcome screen with the project title sleep disorder prediction using machine learning. So just click this login menu here in the top. So now it will be navigated to the login page. So kindly note that this is a static login page because we have not used any database in the project. So just enter the default username and password as admin and then click the login button. You can see the login success message and click OK. So now it will be navigated to the upload part where we need to upload the data set. So inside the project source code folder we have given the upload.csv file. Just select this upload.csv file and then click the upload button. So kindly wait for a few seconds. So there are 15,000 dataset records available in it. So it takes some seconds to load into the browser part. So once it is loaded, it will be navigated to the preview part of the project. So now it is completely loaded. So now let us see the preview part. So here you can see the project data set. So you can just scroll these details and you can find the complete data set has been loaded into the data set preview browser part. As there is more dataset records, you can see it is 15,000 dataset records has been loaded into the preview part. So now in the bottom of the page you can just see this click to train or test button. Just select it. Kindly wait for a few seconds. So now you can see the training finish message and click OK. So now it will be navigated to the important part, that is the prediction part of it. So now let me show you with the few cases of entering the details. So now for the first case, I'll just enter the gender as male, age as 44, occupation as doctor, sleep duration as 7.1, quality of sleep is 8, physical activity level as 60 minutes per day, stress level as 6, BMI category as normal, blood pressure as 125/80, heart rate value as 68, daily steps is 7,500, and here in the final you can see the class called model. Here you can select which model you wanted. So we have implemented the two model, gradient boosting classifier and quadratic discriminant analysis. So you can select whichever model you wanted. So let me select the gradient boosting classifier and then click the predict button. So now it will be navigated to the result part where you can see what are all the input that you have given. I have given male 44, doctor, those details have been shown, and finally you can see the predicted result also. So here you can see this case that I have given contains the healthy. So this patient or this person does not have any sleep disorder issue. So this is the prediction part. So now let me give some other value, so that let me click the prediction menu again, so that we can give for the some other case. So now for the second case, I'll just give gender as female, age as 48, occupation as accountant, sleep duration as 6.5, quality of sleep as 7, physical activity level 45, stress level 6, BMI category overweight, and blood pressure as 130 by 85, and heart rate as 68, daily steps as 6,000, and let me select this time the model as quadratic discriminant analysis and just click the predict button. So now you can see the details, the input values that we have entered, and finally the model that we have selected, and finally you can see the result as this patient is suffering from insomnia class. This is a sleep disorder which I have mentioned you. This patient will be having a problem in falling asleep. So this is the sleep disorder that is being categorized for the input value that we are given. So now let me go to the prediction menu again. For this case, I'll just give the gender as female, age as 54, occupation as nurse, sleep duration as 7.1, quality of sleep as 8, physical activity level 82, stress level as 6, BMI category as overweight, blood pressure as 140/95, heart rate as 72, daily steps as 8,500, and model, let me select gradient boosting classifier itself and then click the predict button. So now you can see the result page with the values that we have entered, and finally you can see the disorder has been classified as sleep apnea. So this is a class as mentioned. So this patient will be having pass in their breath during their sleep, so that the entire sleep will be collapsed, so they cannot able to sleep again. So this is a type of disorder, sleep disorder. So I have shown you with the 3 cases with the healthy insomnia and sleep apnea with the both the model. Finally, let me show you a case with the gender male, age 43, occupation as engineer, sleep duration as 7.75, quality of sleep 8, physical activity level 90, stress level 5, BMI category as normal, blood pressure value as 130/85, and heart rate as 70, daily steps as 8000, and let me select the model as quadratic discriminant analysis and then give the predict button. So now you can see the values that we have entered, and you can see this is categorized as healthy, so that this person does not have any kind of sleep disorder. So in this way you can check with the other cases that is available in the test or in the trained data set with the both the models, and you can just check it out when verify it. So now let me move to the next part, that is the performance analysis part. So once if you click this performance analysis part, it will be navigated to the performance analysis. You'll be having the performance analysis for both the models. So now let us see about the gradient boosting classifier. So the performance analysis part contains the recall, F1 and precision for the 3 cases: healthy, insomnia and sleep apnea. And here you can see the confusion matrix for the gradient boosting classifier with the true and the printed label of it. And next part contains the performance analysis of the quadratic discriminant analysis model with the same true, recall, F1 and precision value with the 3 classes: healthy, insomnia and sleep apnea. And it contains the confusion matrix of this quadratic discriminant analysis with the true and printed label of it. And finally, let us move to the chart part. So in the chart part, we'll be seeing various static data visualization chart, which is about the data set. So first chart contains about the distribution of the classes that is available in the data set. So it contains the 33.3% of healthy data set record, 33.3 sleep apnea data set record, and 33.3 insomnia data set record classes. Coming to the next chart, that is the class count chart, so which contains the count, and the class that is healthy contains 5000 dataset record, sleep apnea, sleep disorder contains 5000 dataset record, and insomnia contains 5000 dataset record. So totally it is 15,000 dataset record. So that is being distributed here in the chart. And next chart contains the distribution of count by age. So here you can see the ages in the X and count in the Y. So here you can see maximum dataset value contains about the age 44, and those details have been distributed here. And next chart contains the profession wise count distribution. So here you can see the profession like doctor, teacher, software engineer, lawyer, engineer, accountant, nurse, scientist, manager, salesperson, sales representative. So in the data set record that we have trained, so maximum data contains about the nurse, then comes the teacher, salesperson, doctor, and so manager contains least value in that. So those details have been represented in the pictorial form in the chart part. And coming to the next chart, it contains the sleep duration versus density. So here you can see the sleep duration and the density chart of it. And next contains the quality of sleep count. So here you can see the quality of sleep, so and the count of it. So maximum 8 has the maximum value of the quality of sleep. And coming to the next, physical activity level versus density. So here you can see the physical activity level from the density value. And coming to the stress level count, you can see the stress levels and the count of it. So maximum people have the 6 level of stress. And next chart contains the BMI category count. So here you can see the BMI class contains normal weight, normal, overweight and the obese. So maximum people that is available in the data set contains the overweight. And coming to the blood pressure count, here you can see maximum people have the 130/85 value as the maximum. Next comes the 140/95 value. And next comes the heart rate density. So here you can see the heart rate density. And coming to the daily steps density, so maximum people have the 6,000 daily steps. And coming to the daily steps density, again the same chart. And next comes the stress level wise sleep disorder count. So here you can see the stress level for each class. So here you can see stress level of 6 contains the maximum count with all the class, that is healthy, sleep apnea and insomnia. And finally comes the occupation wise sleep disorder count. So here you can see for 3 classes for all the occupation that they have used in the data set. So here you can see maximum of nurse having the sleep apnea disorder. And healthy, you can see doctors are having more healthy, and comes the engineers and the lawyers. And for insomnia, you can see teachers and the salesperson having this insomnia disorder. So in this wise you can just show the pictorial representation of the classes of it. So this is the chart part, which contains various static data visualization chart about the dataset record that we have used. And let me log out. And this is all about the project sleep disorder prediction using machine learning, or applying machine learning algorithm for the classification of sleep disorders. And thank you for watching.